The previous video gave a brief introduction on RAppArmor and profiles, and we specifically looked at the user bin R profile. So we showed how the administrator can use the user bin R profile to enforce a single global security policy on every R process for every user. Now in this video we will show how a security profile can be dynamically applied inside a running R process. So if you follow the installation instructions on the GitHub README, your RAppArmor.d directory will contain a subdirectory named RAppArmor.d. And this subdirectory contains a bunch of named profiles, and if you want to know more about how these were defined, you can read the paper which is on GitHub as well. So let's start by having a look at the R base profile. Now this profile actually looks a lot like the user bin R profile that we've seen before. It has very similar file access rules, but there's one big difference in that the user bin R profile was tied to a specific executable user bin R. And this profile is a named profile, so it starts with profile and then a space and then the name of the profile. And profiles that are defined like this are not by default tied to any specific script or executable. They are designed to be dynamically loaded inside a process. So let's see how we use the RAppArmor package to apply profiles like these. So let's start a new R session and load the RAppArmor package. The first thing we see when we attach the package is some information about if RAppArmor is available at all in the kernel at this point, and if a profile is already being enforced. Currently there's no profile being enforced. Actually, we can get this information manually if at any point we want to know what the current state is. We can use the aagetCon function to get the confinement information about the current process, which is currently none, or we can get AA is enabled to see if RAppArmor is enabled or not. If it's not, we get some debugging information on what exactly seems to be the problem. Now let's start by verifying that we indeed have an unconfined profile, so I'll just try to list the contents of the root of the file system, and indeed we get to see everything, so that means there is no RAppArmor profile being enforced at the moment. Now in order to change RAppArmor profiles of from within R, we can use the RAppArmor change profile function from the RAppArmor package, and the argument is the name of the RAppArmor profile. So in this case I'm switching to the security profile that we have here in the left window. Now if this executes without any errors, it just shows a little debugging information, and that means the profile has successfully been applied to the current process, and we can actually verify this using the aagetCon function. So if we run this, we can see that the current confinement of the process is the R base profile, which is in enforce mode. And now if we again try to list the contents of the root of the file system, we will see that this is not allowed. Now note that applying an RAppArmor security profile is a one-way process. There's no way to somehow undo the security profile. So once you ask Linux to start enforcing these security restrictions on your process, there's no way to escape these security restrictions other than exiting the process and starting a new one. So for example, even if I would try to call the change profile function again and try to change in a less restrictive profile, it will simply give me a permission denied error. So at this point it would be safe to run any potentially malicious R code, because it will have no way to do any damage to your system other than things that are allowed by the profile. So the RAppArmor profiles are mostly useful to apply security restrictions to a process. But the RAppArmor package also implements some other tools that are useful in the context of security. For example, it implements interfaces to the Linux rlimit function. And the rlimit function allows you to set restrictions on hardware resources of a process. So for example, you can restrict the amount of memory or the amount of CPU that a process is allowed to use. Now all of the functions that implement this start with rlimit and then underscore. And to understand what exactly they do, you should read the paper or the Linux documentation. But let me just give a simple example in the form of the rlimit as function, which stands for address space. So if we call an rlimit function without any arguments, it will give us the current limits. And the current limit is the maximum value, which is the address space that the process is allowed to use in bytes, which is very large. And we can verify this. For example, if I try to allocate a very large vector, it will do so without any trouble. Now, if I set a limit on the amount of address space in bytes, for example, I want to set it to 10 megabytes, which is this many bytes, then we can see that now this is the limit on the amount of memory that that the process is allowed to allocate. And then if I try to do this again, I will get an error, because in order to allocate this vector, it needs 70 megabytes of memory, and it only is allowed to allocate no more than 10 megabytes. Now, just as was the case for the RAppArmor profiles, applying these restrictions is a one-way process. So, for example, I can always lower the limit to a lower value, but if I try to higher, I'm getting an error. So again, this is if you want to run code which you think might potentially try to use excessive amounts of resources, memory in this case, you can use this function to call it and then run the R code, and you can be sure that the code cannot allocate any more memory than you allow it to. Now, apart from the RAppArmor security profiles and the rlimit functions, the RAppArmor package implements some miscellaneous function. For example, you can set the priority of a process, but also note that just like for the rlimit and the RAppArmor, you can only lower the process priority. There's something confusing in Linux where high values correspond to a low priority. So I can set the priority from 5 to 10, but I cannot set it back to 5. Only a super user can actually increase priority by lowering this value. And there is also the affinity function, which allows you to tie a process to a certain core or cores. So for example, with get affinity, I can see which cores in my machine the process is currently allowed to use. So if I have 8 cores in my machine and the current process is allowed to use any of them, if I want to restrict the process to only use, say, cores 1 and 2, then I would do set affinity 1 and 2, and then if I would get affinity again, I would see this is only 1 and 2. This is only useful if you do something with a lot of parallel computing, because by default R uses only 1 core anyway. And finally, R has a setUID and setGID function, but this can only be used by a super user, obviously. So if we start R as root and then load the package, we can use getUID and getGID, and 0 corresponds to the root user in Linux systems, and we can verify this using whoami, which is indeed root. And then, for example, I can do setUID Jeroen, and then I can ask again, and now it is user 1000, which is Jeroen. And then if we add system whoami, this is Jeroen. Obviously, this can only be done by root, and once you did this, you can not change it back, because only super user is allowed to change into an arbitrary user. So to wrap up this video, we've seen that the RAppArmor package implements a number of interfaces to the Linux kernel that allow you to easily set restrictions and parameters on the current process related to RAppArmor profile, hardware restrictions, process priority, and some other things. But actually, you're recommended not to call these functions directly, but use another function which is included in the RAppArmor package with the eval secure function. And the eval secure function ties everything we've seen so far nicely together into a single function that allows you to evaluate a single R expression under a given profile, hardware restrictions, and so forth. And this will be the topic of the next video. So see you in the next video.